Welcome back to Industrial Automation course. This lecture is about Introduction to CODESYS. Today's topics are as follows. Introducing the CODESYS, creating a new project, writing the LD program, running the program, creating user interface, and modifying the program. And we will have exercises also at the end. What is CODESYS? CODESYS, or Controlled Development System, is a device-independent PLC programming system. Developed by 3S Software, you could refer to their website for further information, and it is in line with the IEC 61131-3 standard. It supports all standard programming languages as follows. So these programmings are supported under this standard. The first one is function block diagram, or FBD. Second, ladder logic diagram, LD. Third, instruction list, IL. Fourth, sequential function chart, SFC. And fifth, structure test, ST. Programming in continuous function chart, or CFC, is also provided, which is not a standard IEC programming language. Okay, so now you should have already installed CODESYS. We had instruction in previous videos and lectures how you could install a demo version of CODESYS, which would be basically enough for the purpose of our project. I strongly suggest you to have that installed before continuing watching this video or reading slides from this point. As we go forward, please work on your software and try this video instruction or slides one by one by yourself to get yourself familiar with the CODESYS software and to know how to navigate between toolbox and parts of the software. Okay, so run the CODESYS program and select new project. Select standard project, which is this one, standard project, and specify the project name and location, then click OK. So these are up to you what name you want to choose or what location. So I suggest you to have a specific folder for the CODESYS in a document folder if you are working in Windows. Anyway, assign a specific folder to CODESYS projects. Specify the controller and the programming language. So here, when you select standard project, then you will see this window. On this window, on the device, go for this specific software, PLC. Okay, just to be consistent with the video, because we don't have these softwares and we're going to work on simulation, so that doesn't basically affect or programming or simulation. Okay, just to be consistent with the project, just video, choose this specific device. And on the PLC programming, choose ladder logic, which is the topic of this slide. Okay, so then double click on PLC programming in the project tree. So we have this project tree here. In the project tree, come under application, double click on this PLC programming. Once you click, then this window will open, and this one, and you will see that this is the area to develop your program. And here you could see your declare variables. Here, this is a toolbox to access programming elements. You could either close or open these windows if you go to the window, basically tab, yes. You could access some of these toolbox here as well on this bar. Okay, now let's start developing your program. Click in the program editor window on number 1, and then click on the contact icon. So this is the contact icon. You could either choose it from here or the toolbox in order to place a contact in the program. So first click here and then click here, and then it will place the contact for you. Okay, so when you place the contact, this auto declare window will pop up, and you will see that on your screen. Here you could choose the type of the variable, and you could name your variable. So just name it start. So this contact would be like start push button, and leave it as Boolean. Okay, so it's a digital input, not the analog input. And leave the other as it is. And just click OK, yes. So go with the default value and click OK. Okay, so as soon as you hit OK, then the new variable will be created in the variable definition window. Okay, so you had this window already, but there was no variable inside. But as soon as you created the start contact, this line will be added. Okay, and if you have a specified value, default value for your variable, you will see that. So here the true default value is specified, but if you just press OK, you haven't assigned any default value to that start, and you won't see this true or false here. Okay, so it means that you could just type your variables directly here and choose that in your contacts and coils. Yes, this is another way to add new variable and then later use that in your contacts and coils. Okay, let's continue our programming by adding a stop button. Insert a negated contact. This is a negated contact here after the start button. So you just need to click here first, and then click on this negated contact. It will place that contact for you here. Same for the start. You will see that declaration, auto declaration window pop up, and then you could choose a name as stop and go with the default value, and then you will see the stop variable in the basically variable definition window. Okay, continue with your programming and place a coil, which is your output. Okay, just click here, then press on coil. You will see the coil in the end of your rung, and then again, same as start and stop, choose the name as motor, and you will see the motor variable here. Okay, now you have a complete program. This program could be compiled and executed. Okay, now the program is complete. We want to compile and run the program. We just need to compile and run it. How? Because we are in simulation mode, first we need to activate simulation mode. Go to the online tab and press on simulation mode from this online menu. Once you do so, then you see this simulation basically tag here will appear. Okay, it means that you are in simulation, so you don't need a physical device connected to run your program. And then in order to start the compilation and running of the program, you need to log into the device and click on the login icon in the toolbox. How to log in? You will see this kind of like a gear which has a plug, power plug attached to that. Just click on this one, this icon, and then this window will pop up, and then you just need to click on yes. Okay, now you are ready to run your program. You are in simulation mode, you already compiled it. To run the program, click on the run icon, this, or alternatively, press F5. Okay. And then you will see your program is in the run mode. Okay, so if a contact logic is true, then it's green in CODESYS. Okay, so for this case here, we have start true, and this is a simple contact. So this one is true, this one stop is false, but since it's negated, then the stop will be the negated contact also will be true. Okay. Once you are in the run mode, you will see that there is a run green bar appears at the bottom of the window close to the simulation. So it helps you to avoid confusion and know exactly what is the status of your program, plus the value of the variables you could see in this basically window, which is a variable declaration window. And on this case, none of the start and stop are pressed. So start is false, stop is false. This contact logic is true, and this one is false. Yes, and the output is not energized. Okay, how we could then change a value of our inputs or contacts in simulation mode. Once you are in a run mode, you could just click on the prepared value and switch between possible values for that specific variable. So since we have a Boolean variable, the possible values will be true or false. So if you click once, you'll see true, then the next one false. And by each click, you are changing a prepared value, and you see a prepared value close to that contact. Yes, still the logic of start is false, and this is a prepared value. Yes, not a true value of this contact. Once you're happy with the prepared value, then you need to press on F7 to force it. Okay, once you press on F7, you will see a sign close to that contact, and you see the logic of that contact has changed. Now, if you want to make that value permanent, then you need to press Alt F7. Okay, so you need to hold Alt and then press F7 or Alt plus F7. So once you do so, then that F sign will disappear and this true value will become a permanent value of that variable. So here you are, we have a new permanent value for the start. Okay, so try to change a start and a stop variable both and see what is the effect on the output. And finally, check if you could force the coil value. Yes. And see if you could force it, are you able to make it permanent or not? Okay, I'm gonna leave that to you. Okay, so since we are using simulation and not a real device, and not real input devices and outputs, we might have some difficulties of understanding what exactly is going on by changing status of start and stop. So to just replace the real device and make it easier for us to understand or program, we could use visualization in CODESYS. How we could add visualization, we just need to follow these steps. Click on application, then on add object, click on visualization. So once you click on this visualization, it takes some time to load the visualization and associated toolbox. So be patient and give the software some time. Okay, so you need to choose a name and add. And finally, you have this visualization tab here and toolbox. From this toolbox, you could add lamp switches, bitmaps, and etc. Okay, we will work with the visualization more in coming lectures. Okay, now let's add push switches and basically make it or start and stop push buttons. We just need to basically click on lamp switches and then push switch and drag it and drop into our visualization window. Okay, so here you are, we have our push button here. Once you do so, then you will see properties window of this push button. Okay, the most important property is the variable. You want to associate this push button with a contact or variable. Okay, just click on the variable here. Okay, and then click on these dots and browse in between your variables and click on start, choose start. You will see the start selected and then press OK. Now this push switch is associated with start variable. Keep other variables as default. Now place another push switch and associate it with the stop variable and change the background color to red. Now place a lamp and associate it with the motor variable. Okay, now you have your full visualization, and you could log in and run the program. Now you should be able to operate the switches and see the status of the motor. Try to change the status of inputs and see the effect on the output. Okay, so just press on these push buttons and see the effect on the output. It is sometimes useful to see the variables all together. To do so, right-click on the name of the variable in the variables area of the PLC programming and select Add Watch. Okay, so you could have different watch lists, and if you do the Add Watch, you will add it to the first watch or watch 1, and then you will be able to see this watch list in your visualization as well. Add watches for all 3 variables. You should be able to see their values from visualization window as well in the runtime. Now let's modify the program. We want to have the motor running as we press the start switch and release it. Okay, so you might have noticed now that in the program we have already, if you press start and keep that, the motor will be on. If you release it, again the motor will go off. But we want to press start, and when we release that start button, we want that motor or output to stay on. So just when we press the stop switch, the motor will stop as before. One way is to put the motor contact in parallel with the start contact. Okay, so here we want to have a parallel contact to the start, and in that parallel branch we want to have a motor contact, okay, which we call that latching. To create a parallel contact, select parallel contact 1. So here, see in the toolbox, and place it where you see the arrows close to the start contact here. Okay, so if you do so, then you will have a parallel branch. After placing the contact in parallel with the start contact, determine the variable name for it. Okay, so in that parallel branch, the new branch, we have a contact, and we want to associate a variable with that contact, and that will be motor. Okay, now you could log in again and run the program and observe the functionality of the program by changing values of start and stop switch. Now if you press start and release it, the motor or the output will stay on, because we will have a logical continuity in the parallel branch. Okay, so I'm going to leave that to you to do practice yourself and see the effect of this new change. It will be useful to have labels in the visualization. These are what we call labels, okay, start, stop, motor, to make the functionality of different components clear. Insert labels from the toolbox and use the suitable text for each one. Okay, so in the toolbox, in the visualization window, you could select label for each. In order to add a new rung, right-click on the left-hand side here of the rung and select Insert New Rung below this basically item. Okay, the number 1. So you click here, right-click, and then choose Insert Network below. Okay, so this pink bar will be extended more, and will give you a new space to add a new rung. Okay, then you could add a new rung, place a contact, just click on contact icon once you are in the new network, and associated with the start variable. So we are now expanding our program now. This is the previous program with the latching of the motor. And in this program, you could see again, when we press start, the motor will turn on. This contact then will be true, and even when we release the start, and this contact will go false, since this contact is true, we have a logical continuity, and the motor will stay on until we press stop. When we press stop, then it will go off. Okay. Now we are expanding our program, and in the new program we are going to introduce a new coil, valve coil, and we are going to use a set and reset coils. Okay, so in the second network, we already press we already placed a start here. Now use this set coil and insert a new set coil here. Define a new variable, valve coil, and then insert a new network, the third network. This is the third network, and then create the new rung with the stop contact and set reset value, reset coil for the valve coil. Okay, so this is basically equivalent version of the previous program here. So here, when we press start, the motor will go on, the new valve coil will go on, will be true because we are setting that to be true. And even though we release a start and this contact becomes false because we already set that valve coil, it will remain true. Yes, so this is kind of equivalent to this first network. Okay, and when we press a stop, then we could reset that valve coil. Okay, so it will remain on until we press a stop, and then when we press a stop, we could reset the valve coil, and then will be false. Okay, so these two rungs will be equivalent to this rung 1 in the network 1. Okay, so do the visualization and see the effect of pressing start and stop on the valve coil. So add a new lamp, and a new lamp associated with the valve coil, and see the effect of pressing start and stop button on the motor and the valve coil. and see the equivalency between these two networks. Okay, so here we have an exercise for a practice. I suggest you to work on this exercise by yourself, but the solution also is provided on this link. So you could refer to the link and basically see the solution, but please try to work on the software yourself and try to come up with the solution. It would be a nice practice for yourself. What do we have here? We have this water tank, and there is a pump motor attached to this tank. The pump basically pumps the water out of this tank. We have some inputs, on and off switch, which we could turn the motor on and off. We have manual and auto switch, which we could basically switch between the manual mode and auto mode. We have two sensors. So these are again our inputs to our PLC. We have high sensor switch, which measures the level of water when it reaches to the sensor and will send a true signal or one value to the PLC. And once the level of water reaches to the low sensor, then the sensor will be activated and will send a one signal to the PLC. We have some outputs. The outputs are first the pump motor. Okay, so we need to turn on and off this pump motor by our program. And we have some pilot lights here. We have green, red, and yellow lights for indicating if the pump is running or if we are in the low level or if we are in high level. Okay, so in our program, we need to consider these specifications, yes? We want to satisfy these specifications here. In the manual mode, the pump will start if the water in the tank is at any level except low. Okay, so once we are in the manual mode, if we switch this on and off to on, the motor should start pumping water out of the tank if the level of water is not at low. Okay, so at any level, we should be able to manually turn on that motor. In the automatic mode, when the level of water reaches the high point here, the pump will start automatically. Okay, pump will start and will stay on. And when the water level reaches the low point here, the pump will stop automatically and will stay off as far as we are at this low level. Okay, you can push switches for the high, low sensor switch. So you can use in the visualization, in the CODESYS, yes, in the CODESYS, you can use push switches for the high-low sensor switch and change their status manually to simulate the change in the level of the water. Okay, again, the solution is provided in this video, but please try to think about your program yourself in the CODESYS, try to program it, visualize it, and then finally refer to the solution and see what are the differences between a perfect solution and your solution. And you might have you might have an alternative solution, yes? So your solution could be as perfect as the solution provided in this video, but not exactly the same. And then you will see that in PLC programming, we don't have a unique solution, and both of the solution could work exactly the same, but it's just a matter of optimality and professionalism in your programming, yes? Okay, we have another exercise. This exercise, you have to submit it to the Moodle. Please do it yourself and submit it. This is basically a overhead garage door. Okay, this is an overhead garage door. A motorized overhead garage door is to be operated automatically to preset open and close positions. Okay, so once the door is completely open, we are in this preset open. Once the door is completely closed, we are in the closed position. This is the motor. Okay, and let's see what inputs and outputs you have. So you could use in your program and visualization. First, we have a reversing motor contractor for the up and down directions. So we have this motor, and this is our output, one of the output, this motor. We have normally closed down limit switch to sense when the door is fully closed. This is at limit switch 2. We have a normally closed up limit switch to sense when the door is fully open. This limit switch here. We have normally open door up button for the up direction. So it's basically this open push button here. When we press this, then the door will go up. Have normally open door down button for the down direction, which is this close push button here. Okay, you see basically they have I symbol at the beginning. It means that they are inputs. Yes, these limit switches are input. The motor is output. These push buttons are inputs. We have normally closed. Okay, so this is the difference. The two other ones are normally open. Have normally closed door push button for stopping the door. Yes, so at any point, if we press the stop, it will stop the motor from running and the door will stay half open at any position. And you see the difference between the stop buttons and let's say start buttons is that usually stop buttons are normally closed, yes, but two other ones are normally open. So it means that in all programming, we could just use a normal contact, and that normal contact will stay true until we press that contact and will basically becomes false. Okay, we have some lights. We have red door ajar light to signal when the door is partially open. Okay, this is the light when it's partially open, when we are not in the open and close positions, when these limit switches are not activated. And we have green door open light to signal when the door is fully open. Okay, so when this limit switch is activated, this light should be on. And we have yellow door closed light to signal when the door is fully closed. Okay, so these are our inputs and outputs. And you should come up with a program which could satisfy the needs of our design. What are the sequence of operation we need? So in your program, yes, when the up button is pushed, the up motor contractor energizes and the door travels upward until the up limit switch is activated. When the down button is pushed, the down motor contractor energizes and the door travels down until down limit switch is activated. When the stop button is pushed, the motor stops. The motor must be stopped before it can change direction. Okay, so these are our needs, and these are the sequences in operation of our PLC program. Okay, we have a solution here for the exercise. You see the inputs up limit, down limit switches, door up and door down, normally open switches, and we have normally closed stop switch here. We have outputs, door ajar, red light, door open, green light, door close, yellow light, motor contractor up and motor contractor down, yes? And we have two addresses for output of the motor. One is 043 and the other one is 044. Before looking at this solution, try to do it by yourself and finally compare it with this solution. Do it in CODESYS, do the visualization, check your program and submit it to Moodle. And this slide finalizes this video and this lecture.